In this lesson, we're going to create a 2-day scenario, and I'm going to call this Astrogator. And for my stop time, I'm going to write in plus 2 days. I'm going to click OK. And what we're going to do is we're going to insert a satellite object, just using the insert default method. I'm going to close out of this. So we're going to go into our satellite object's properties, and we're going to change the propagator from two-body to Astrogator. The first things we'll see are the default initial state and propagate segment. Any satellite that you're working with within Astrogator needs an initial state. Other initial states you can use are launch segments, or follow or hold segments. We're going to keep this initial state, and the only thing we're going to change is the coordinate type, and we're going to change it to Keplerian. There are 6 major parameters that define an orbit that you can see listed here. We're going to change the eccentricity to 0.015. So we're making a slightly elliptical orbit because a perfect circular orbit would have an eccentricity of 0. Next, we'll take a look at the propagate segment. Now, underneath the propagators, we can change the propagators. The default is Earth HPOP. If we select the ellipses, we can take a look at the other provided propagators. Now we can see from these icons that these are objects that we can edit within the component browser. And you can find the component browser icon and access it from here. So the propagate segment we want to include in this segment needs to have a stopping condition. And the stopping condition that we're going to set is going to be to stop at periapses. Right now it's set to stop at a duration. If we take a look at the trip time down here, we can see that the duration stopping condition is set to half a day. So we can add a new item to our list, and we can go down here and select periapses. And we can uncheck duration or delete it to remove it from our list. So we can set the periapses here, and now the periapses is the closest point to the origin. Underneath the propagate segment, you can also define different constraints and other parameters. Instead of stopping at the first count of the periapses point, we can change this and have it stop at any later periapses point. Something to highlight here, just as a reminder, so when we have a propagate segment, we are having the satellite propagate using our definition of the propagator, so in this case HPOP, until it meets its stopping condition, so until it meets its periapses point. Now that we've defined our stopping condition, as the periapses point, we can take a look. So we have our initial state that is set to 0.015 eccentricity, and now we can take a look and actually run this mission as well. So I'm going to close out of these things. To run a mission, you can select the green arrow button, or if you select the drop down, you can choose to run only certain segments. We're going to run the entire mission right now to take a look at the results. So we can see that we have now drawn out our orbit, and now it has come to its new periapses point using the initial state and propagate segment that we defined. The next thing we'll do is model a maneuver to change our orbit to reach a higher altitude. To add a little perspective to our mission, we're going to insert a grid to give us an idea of this orbit and its path. So from the 3D Graphics Windows Properties page, we're going to go to Grids and turn on Show ECI Coordinates and change the color, hit Apply and OK. So now we've inserted the ECI coordinate frame. We can take a look at it and see that it is lined up along the equator. And this will also give us some understanding of the different parameters of the satellite's orbits and how their changes affect it. Now that we have our window set up, we can go in and insert that maneuver element. So we're going to insert a maneuver segment using the Insert New button. So we're going to select Maneuver and bring that in to our segment. If things don't come in order, you can just drag and pull the segment until it is in the proper order. From this segment, we can take a look at its properties. So the maneuver type can be either impulsive or finite. And we can choose our attitude controls to either be along the velocity vector or break it down to different components and define those for our mission. For this case, we're going to have our attitude control be along the velocity vector, and we're going to give this a delta V magnitude of 1 kilometer per second. Now after this, we're going to insert a new propagate segment because we want to know to this orbit following this maneuver. So we're going to right click on the maneuver and insert after, and we're going to insert a new propagate segment. If you right click on any object in the MCS, the mission control sequence, you can go in and rename it. So I'm going to call this prop to apoapsis. And I'm also going to rename our first prop segment to prop to periapsis. So you can also right click on an object to go in and change its properties and update its colors. And I like to make the maneuvers white because this is an impulsive or instantaneous maneuver, and that way I won't get distracted by the colors. And now I need to define my stopping condition in my prop to apoapsis. So I've already titled it to prop to apoapsis, so the stopping condition I'm going to use is going to be the apoapsis stopping condition. And now I'm once again going to uncheck and just delete that duration segment. Now that I've defined my new stopping condition, I can go take a look at what that result would be. So now I'm going to run my mission control sequence, and I can take a look at the new orbit.